We're going to take parts of Module 4.2 and 4.3 for today's screencast on energy balance and body composition. We're going to look at positive versus negative energy balance and its effect on weight maintenance, weight gain, weight loss. We're going to look at the components that make up energy intake and the components that make up energy expenditure. And here on the right, those components, just by way of brief introduction, are basal metabolic rate, physical activity, and the thermic effect of food. So what we're actually doing are going into detail what you folks are going to be doing for your diet project. You're going to be calculating your energy intake and your energy expenditure. We're also going to look at body composition, what a healthy body composition consists of, some of the methods used to determine body composition, the difference between weight and fat distribution. Where fat is found on your body may affect your risk for disease. First, let's look at some principles of energy balance. A pound of fat is equal to 3,500 calories. To lose body fat, a calorie deficit needs to be created. You need to be in negative energy balance. To gain weight, a calorie excess must be created. You need to be in positive energy balance. Body weight changes are based on this relationship between calorie intake and calorie expenditure. When calories consumed are equal to calories expended or used, the body is said to be in energy balance, and weight should be maintained. When calorie intake is greater than calorie expenditure, the person is said to be in positive energy balance, and weight gain can occur. If calorie intake is less than calorie expenditure, the person is said to be in negative energy balance, and that often results in weight loss. So the energy intake portion of our equation refers to calories. All those calories that you consume from beverages and food add up. The question is, where did those numbers come from? And at the beginning of the semester, you may remember we looked at the Baum calorimeter. And just by way of reminder, what happens in this Baum calorimeter is that food is burned into nothingness. All that's left is ash or minerals. It's placed in a compartment surrounded by water. That water is heated up, the temperature is measured, and the difference between when the food first starts to be heated up and when it's gone, when it's been burned up, is a measurement of the energy that is released when the bonds connecting the carbons and the hydrogens are broken. That heat released is also known as calories. Energy expenditure includes basal metabolic rate, the amount of energy needed to sustain life, voluntary muscle movement, the calories burned in physical activity, and what's called the thermic effect of food, the energy required for food digestion and processing. Between 60 and 65% of the calories we consume are used for basal metabolism. Between 25 and 35% can be used for physical activity. And the thermic effect of food, sometimes referred to as dietary thermogenesis, is between 5 and 10%. For your diet projects, you're using the 10% figure. BMR is the energy required by the body to minimally function. These are the involuntary activities that are going on in our body all the time. Imagine what would happen if you had to remind your heart to beat or your lungs to breathe. Well, don't do that. That's why it's called involuntary activities. It is determined in a fasting state and when the body is completely at rest. And as you saw from the previous slide, the majority of energy expenditure in a sedentary person is for basal metabolic activities. There are different factors that can affect basal metabolic rate. Age, as we get older, our BMR decreases. I hate that. Gender, males tend to have a higher BMR than females due to their increased muscle mass. Physiological state, this can refer to illness, fever, fasting, malnutrition, and to body size or surface area. To explain surface area, I want you to look at these two items here. We have two sets of, let's call them boxes. They each have 4 sides, but they're stacked differently. The one on the left is stacked in a 4x4 fashion, and the one on the right, each of these 8 boxes is stacked on top of each other. What is important about this is that the group of boxes on the left has a lower surface area than the one on the right. That is determined by counting up the number of surfaces exposed to the environment. This one on the left has 4, 8, 12, 16, 20, 24 surfaces exposed to the environment, while the one on the right has 34 surfaces exposed to the environment. The one on the right has a larger surface area. Now imagine that these are two people. Both of the same weight, one tall, one small. The taller one will have a greater basal metabolic rate because they have a larger surface area that requires more energy to maintain body temperature. It takes more energy for this person with a larger surface area to maintain their body temperature at 98.6 degrees Fahrenheit or 37 degrees centigrade. So this tall person has a greater BMR. The second component of energy expenditure is physical activity. This is voluntary muscle movement, and the amount of energy expended increases with body weight and intensity of exercise. The third component is known as the thermic effect of food. This is the amount of calories that our body charges for processing, for digestion, absorption, and assimilation of nutrients. Now let's look at body composition. Healthy body composition includes lean body mass, essential fat mass, stored fat mass, minerals, and water. Actually, an unhealthy body has all these components as well, but the percentages vary. And there's a difference between body weight and body fat. Our scales don't accurately tell body fat. There are a number of different ways to determine this. You can use underwater weighing, which is very accurate and expensive. The BOD Pod, which I'll show you in a second, also extremely accurate and even more expensive. Skin calipers. What you need to know about skin calipers is that the more sites you use on the body, the more accurate your results, but also the more experienced you are at using skin calipers, the more accurate your results. A method called bioelectrical impedance, the Futrex 5000, and then there are techniques that are used in a research environment, such as the DEXA, which is also used to determine bone density, an MRI, body potassium, substance dilution. These are things that are not being used in the general public, but are used as part of research. And here are some pictures: underwater weighing, electrical impedance, the BOD Pod, and skin fold calipers. Then there's of central adiposity, or the pear versus the apple shape. It's determined by weight measure. Body mass index is another tool used. It is a measurement of body weight in relation to height. It is not an accurate measurement of body fat. Studies suggest that using BMI and waist circumference can show if an individual is at increased risk for heart disease, hypertension, dyslipidemia, and type 2 diabetes. See, these two guys, they're the same height, they're the same weight, they have the same BMI, but what do you think about their risk for disease? This is why BMI is by itself is not a good tool, because it doesn't tell us anything about body composition. In summary, energy balance is the state of energy intake versus energy expenditure. The intake part of the equation is calories or food consumption. The expenditure includes BMR, physical activity, and the thermic effect of food. Positive energy balance occurs when intake is greater than expenditure. Negative energy occurs when intake is less than expenditure. It's also helpful for folks to know their body composition. There are different methods to determine body composition and where fat is found in the body, the way it's distributed, and we'll talk more about visceral versus subcutaneous fat can affect risk of disease.